Welcome to the NestJS tutorial from scratch. In this series, we already seen how to initiate or scaffold the NestJS project. I explain the NestJS project structure. I make a connection to with MongoDB from NestJS project, and next I build the CRUD APIs of the tasks, create, read, update, delete APIs. So you can see the Swagger UI from the Open API spec or the Swagger UI. We tested all the APIs. We have the default APIs which gives us response hello world. Other than this default route, we have this slash task, get the list of the task and create new task, get task by a specific ID, update a task and delete a task. And we also have this task schema. So you can check the link of this video in the upper right corner. And if you are interested to build a full stack web application from scratch by using Node.js, Mongo, Express.js and React.js, you can check the playlist link in the upper right corner. And you also can learn the front-end technology AngularJS from scratch. I also have the playlist. You can check in the upper right corner. Today we will start building a scalable microservice architecture with NestJS. First, I will explain the difference between the monolithic and the microservice architecture. Next, I will introduce the microservice architecture, and then we will create the different components of the microservice architecture with NestJS hands-on. So let's get started. So first, I will explain the difference between the monolithic and the microservice architecture. So basically, the monolithic architecture is a traditional approach where the entire application is built as a single and tightly coupled unit. The components and functionality are bundled together in a single code base and deployed as a single application. If I give you an example of the e-commerce application, in the left hand side we have the monolithic architecture of the e-commerce application, and in the right hand side we have the microservice architecture of the e-commerce application. So you can see for the monolithic, all the components are tightly coupled. The feature, customer service, product service and cart service are interconnected and run in the same process space. And we have the single instance of the database where all the customer service, product and the cart related data stored. Now if I come to the microservice architecture definition, microservice architecture is an approach where a large application is broken down into smaller independent services that communicate each other through well-defined APIs. Each services is developed, deployed and scaled independently. Now if I go to the same example, in the right hand side you can see we have the different microservices for the customers, product and the cart, and they are interconnected with each others. And we have the UI microservice which manages the connectivity between those microservices when the client requests to any services. So here each service operates independently and communicates with others through APIs. If I go to the next comparison, we have the development and the deployment. In the monolithic architecture, developers work within a single code base, making it easier to understand the entire application. And in case of the microservice, developers work on smaller independent services, allowing for greater agility and the parallel development. Now if I come to the deployment involves deploying the entire monolithic architecture, and any changes may require redeploying the entire application. And in case of the testing is comprehensive but may be time consuming due to need to the test entire application. So of the microservice architecture, deployment involves deploying individual services independently, enabling faster and the more frequent release. And in case of testing, that can be more focused on specific services, facilitating quicker testing cycles. Next, we have the scalability. So in terms of scalability, monolithic architecture scaling is typically done by replicating the entire application, may result in inefficient resource utilization if certain parts of the application requires more resource than others. And in case of the microservice, granular scalability allows for scaling individual services based on their specific demands. efficient resource utilization, as resource can be allocated where they are needed most. Next, we have the technology stack. A single technology stack is used across the entire application for the monolithic architecture, and here the technology upgrades or changes may require modifying the entire application. But in case of the microservice, different services may use different technology stacks based on the specific requirements of each services. And technology upgrades can be implemented gradually on a service by service basis. And next we have the development speed. So initially faster development, as there is a single code base and development environment for the monolithic architecture. And over time, as the monolith grows, development speed may decrease due to the increased complexity. And in case of microservice, the slower initial development, as some more consideration is needed for services boundaries and communication, but the faster iteration and the development in the long run due to the ability to deploy and update services independently. Next is the failure isolation. So a failure in one part of the monolithic application can potentially impact the entire system. But in case of microservice, failure in one service generally do not affect others. It's improving the fault isolation. Next, we have the service discovery and communication. So in case of the monolithic architecture, communication is typically through direct method calls or shared libraries. In case of microservices, services communicate through well-defined APIs, often use HTTP REST or message queues like the RabbitMQ or Kafka. Now I will discuss the key consideration for designing the different components of the microservice architecture. First, we have the service discovery and registry. The objective here is to enable microservice to dynamically discover and communicate with each other. In this video, I will discuss about the service registry and the service discovery. We will create a service registry by using NestJS, and we will see all those components of the service registry, and we will discover different service, registered service and unregistered service. So we will first talk about the implementation of the service discovery and registry. In the picture, you can see the client actually first request the load balancer for a specific service. Then the load balancer get the informations of the service, like the metadata informations like the IP and the port of the service that clients wants. And next, load balancers query this particular service to get a response and get back to the client. And if I talk about the service registry, so service registry is nothing but the register of services available. So we use the service registry to store information of the available services. And the services when they start up basically register themselves in the service registry and periodically refresh and update the service informations. Next, if I talk about the service discovery, so to implement a service discovery mechanism, so we can do on the client side of the server side. So basically client query the service registry to discover the location like IP port. Here the load balancer do its inquiry service registry to discover this location and leverage DNS based discovery or utilization APIs for the service locations. Next, I will show you the APIs of the service registry. So you can see we are going to build this set of APIs, add or update a service. So if I go to here, add or update service, we have this endpoint 3000/service registry, and it is put request, and we have to provide the name, version and the port of the service. Suppose we have the to-do service, and if I register this service, you will get this message, the service added or the registered, and you can search the service here by providing this service name and the version. It's partial search. So suppose right now we have a 0.0.1 and I am adding the another one 0.0.2 and one more 0.0.3. We have the three different versions of the to-do service. Now we can search the service by providing this 0.0. First, it fetch the 0.0.3 version. Next is fetch the 0.0. It's randomly pick the pick the version of the service to balancing the service. And next, I can update the service by providing the same informations, the name and the version. So if I click on this, so you can see the service. It should be service updated. You can see the service is updated for the 0.0.3. The service updated here, and I can get the different timestamp of this service. So basically, upon update the service is update the timestamp of this services. And we also have the delete or the deregistered service on the service registry. So if I deregister or the delete the service from the registry, we will not find this service like the 0.0.1. If I search now, service not found. And you can see we have the service 0.0.2, but the 0.0.1, the version of this service deleted. We have the service not found. Now I will start building the service registry by using NestJS. So we already have the my NestJS project, which is basically our task project, create, read, update, delete task, and I will rename as the task pro service. And now I will initiate the service registry in the same directory in the NestJS tutorial. And the command was nest new service registry. And next I will create the controller for the service registry, the controller file and the service file and the module file. I already explained those the previous videos of this series. So the NestJS initial project structure for the service registry created. Next I will create the module service and the controller. Next I will change the directory to the service registry and create the module service and the controller. Now I will go to the service registry service.ts and I will add the service for the register, unregistered, and search for a service. First I will define the services storage, and its type will be object, which will contain the key. The key will be unique. Based on this key, we can identify the service. Next, in the constructor, I will initiate the services. Next, I will write the register function where we can add the service. It will take the name, version, IP and port of the service. And it will return the key, the unique key of the service, and also a message. So I will use this register message to add the service, also the update service. So the message will be either service successfully added or service successfully updated. So if the service not registered, then I will add new entry. First, I will create the unique key by combining this input, the name plus version plus IP and port. And next I will check if the service is present or not. If the service not present, then I will add a new entry. So here I am taking the timestamp of this particular service in second. Next I will assign the IP, port and version. Next I will log the message the service successfully added in our service console. Next I will return the key and the message successfully added service. And if it already exists, I will just update the timestamp. Next, I will manage the stale services. In microservice architecture, managing stale services is crucial for maintaining the health and reliability of the system. Stale services basically are instances of microservices that may no longer be responsive or functional. So here, I will add a cleanup method here in the service registry to periodically check the stale services. And the cleanup logic will to configure a timeout for considering a service as a stale. So here I will took the timeout of 30 seconds, and I will write the cleanup method next to the register. First I will track the current timestamp in seconds. And I will be rounded down it. Next I will iterate over the keys of the services objects. After before the registration, I will clean up the stale services. Next, I will write the unregistered service. The unregistered service will just generate the key. In the unregistered service, the IP port and the version will be provided. It will generate the key, and it will just delete this service from the services object and log the message. I will write the controller to handle the registration of the service. I will import the service registry. This service registry service. Next, I will take in the constructor. to see the registry register method, it took the name, version, IP and the port. IP I will extract from the request. So I will write a method which will extract the IP from the request. First I will retrieve the X forwarded for header value from the request header. Now I will get the IP, but by get IP address call, and I will provide the request. Next I will call the register method in the service registry service. Similarly, I will write the unregister method or the unregister controller. It will be the delete route. We will have the get uh, get service or the search service. I didn't write the search service which retrieves a service based on its names and versions from the service registry. So in the service registry service.ts, I will write this method search service. And for the service version comparison, I will use the Semver library. So basically, the Semver library is a common library used for the versioning, and here I will use for the version comparisons. So I will import star as Semver. Version here is string. Only the port is number. It is perfect now. Now I will call this from here. So it will also return any. So I'll call this method the service registry dot search. Everything is okay now, and I will look into the service registry module. We have this service registry service and the controller also included. And now if I start the server as the development mode, npm run start :dev, you can see the log here. Our service registry APIs are ready. We can test from Postman the add or update service into service registry, unregister a service and search a service. So I will go to the Postman and I will first add a service. This name to do service version 0.7 port 7007, and you can see the service successfully registered with the key. And if I check the log here the service registry debug log added service to do service at this the IP6 address and the port with version 001. Next, if I hit the same request, then it successfully updated, and here is the updated service to do service. We also have the removed services. So for the removed services, I will make it 1 instead of the debug, and same for the cleanup. And as the server restarted, so our service object will be clear. So we have to request from a new the service successfully registered. And if I search the service, so you can see the service not found. So I debug this issue. So if you check the register method here, so we assign the timestamp IP port version but not the name. So we have to also assign the name so that it can matches in the find. So we don't have name. So I fixed it, and next here you can see we have the filter here, but we didn't return this expression. So if this expression is true, then we will get the candidates of the matching name and this version criteria. Next, I will test it. So I will go to add update service and I will add the service. So you can see service successfully registered. Next, I will search the service, and you can see it's giving me the service name, and please identify the timestamp. We have the 573. And next, if I update this service, if you query the same service, you can see the timestamp updated here. And if I check the log now, you can see the log, the added service here we have, and the service is added here with these parameters, and we also have the updated service. Now I will wait for the timeout, which we have the 30 seconds, and after 30 seconds, if I search, it will be removed as a stale service. So now if I search, so you can see service not found, and here we have the warning removed service. This service is removed as a stale service. Next, I will add the same service and I will delete or unregister by calling the API. So service successfully registered, and if I check it, we have this service, and if I unregister this service, so you can see the service removed, and if I check the log here, the removed service with the version, and if I search here, the service not found. So the 3 APIs are working as expected. Okay, so that's all for this video. In the next part of this video, we will register, unregister. We will integrate the register and the unregister API of the service registry to register this service, this task service, and we will call this registered in the interval, in a certain time interval. And if any error occurred, we will clear this interval and unregister this service. So please stick to this series, and I hope you like the video. If you like the video, please hit the like button please share my video and please subscribe to my channel. Thank you.